All right, so the second derivative test tests for concavity. Does anybody know what concavity is? Okay, well, yes. In fact, I've got a dentist appointment today, and hopefully they don't find any concavities. All right, so, but concavity is basically the way a function curves. All right, so on this particular, I've got a portion of this that opens downward. Okay, so that portion right there opens downward. And then it changes, and this portion opens upwards. Okay, this, when it opens down, is concave down. This is concave up. This little piece right here in the middle, that piece is neither. It's neither concave up or concave down. Okay. A little bit more info on this. This function is increasing. Okay, and how do I know if it's increasing or not? Good. First derivative test. If the first derivative test is positive, it is increasing. So in this area, we're decreasing. Okay, and that's what it looks like, and then it's increasing again. Okay, so I have concave up, concave down. I have increasing, decreasing, increasing on this particular function. Okay, this one here is decreasing. All the way. And then probably at this point right here, it's neither. What does that mean for the slope? 0. And then this would be increasing again. What's the concavity of this? The whole way, right? So it's concave up the whole way. Okay, so the way I look at this is if it were a cup or if there were water in this curve, would it hold water or would it not hold water? Okay, so for example, this would not hold water, concave down. This would hold water, it's concave up. This whole thing would hold water, concave up. That's just kind of the way I do it. Okay, that's the way I would look at it if I were looking at a graph. Okay, so here it is, the test for concavity. If f is a function whose second derivative, so we've studied second derivatives, and some of you ask when we ever going to use second derivatives. Does anybody remember what I said? Okay, if I give you a position function, like a function of somebody's position with time, if I take the second derivative of that, I get their acceleration. If I take the first derivative of it, I get their velocity. So position, first derivative is velocity, second derivative is acceleration.
What's the third derivative?
Third derivative is something called, I think it's called a jump. That's what I said. And I'm not really sure conceptually what that is, but I had somebody tell me that. You can Google it and find out. In curve sketching, the second derivative tells us concavity. Right? The second derivative tells us if something is concave up or concave down. And here it is. If the second derivative is positive, it's concave up. If the second derivative is negative, it's concave down. And if the second derivative is 0, what do you think that means? It's neither. All right, moving on. So here's our first example. F of x is equal to 6 over x squared plus 3. Determine the intervals on which the graph is concave up or concave down. All right, so what do I have to do to find out if it's concave up or down? Got to take the first derivative first. Okay, that's the first thing. So I'm going to start over here. F prime of x is low d high x squared plus 3. What's the derivative of 6?
0.
0, good. Minus, so there's low d high minus high d low over low squared. Okay, so cleaning that up, f, the first derivative is equal to negative 12x over x squared plus 3 to the negative 2. Okay, everybody good with that? Now what do I do to get the second derivative? Take the derivative again. How many of you would do the quotient rule on this?
Well, I think it'd be chain and quotient.
It will be chain and quotient, but there's another way to do this using the product rule. If you made that, this should not be negative 2. That should be positive. If you move that up and make that a negative 2, then you can do the product rule on it. It's whatever you're most comfortable with. I'm going to use the quotient here because I think that's how most people would do it. Low d high minus high, which is negative 12x, d low, and this is where you're saying chain rule. So this is going to be 2 times x squared plus 3 to the 1 times the derivative inside, which is 2x. All of that over low squared to the what? 4th. Any questions about how I did that?
Would you simplify that at all?
I would clean that up a little bit. And here's how I would clean it up. I have x squared plus 3 on the bottom. I have x squared plus 3 on top. And I have x squared plus 3 right there. Okay, so I'm going to factor out this x squared plus 3, then I'm going to reduce it with what's on bottom. Okay, so the way this goes is f double prime of x is equal to, and I have x squared plus 3 squared, so I have 2 of those here. I only have 1 of them here. So which one do I?
X squared plus 3.
Yeah, I can only factor out 1 of them. That's the most that I have. All right, and then I'm going to put this big bracket because everything else goes in there. All right, so how many are left whenever I factor out 1 of these? Just 1. And I'm going to put times negative 12 here. Minus, and then I've got, let's clean some of this up. That's going to be 2 times negative 12 is what? Negative 48. X and x is x squared. And then when I factor out 1 of these, what's left? Just the number 1. Okay, and that's all over x squared plus 3 to the 4th. So this cancels with 1 of these, and I'm left with 3. So if we clean this up a little bit, negative 12 times x squared is what?
It's 12 x squared.
Negative 12x squared
Minus 36.
minus 36 plus
48.
48x squared. All of that is over x squared plus 3 to the third. And then cleaning that up again, I'm left with 36x squared minus 36 over x squared plus 3 cubed. And so what do I end up with here? Factor out of 36. Can y'all see that still? X squared minus 1 over x squared plus 3 cubed. Okay, that's a lot easier to work with. That's not too bad. That's a lot of cleanup. What is that? That's algebra. Okay, so before you go off to college, make sure you know algebra very well. Anybody in here considering taking college algebra at ACC? Anybody taking it yet? It's not a bad idea, really. I don't know if you were motivated enough to do it your second semester of your senior year, but the thing about calculus, and the thing that I think as you go to college, what you really need to know is you need to know how to do algebra, but then you need to know that you know how to do algebra. Like, you need to have that confidence that I'm doing this right. I'm not doing anything illegal here. Because if you're constantly second guessing yourself, you're going to have trouble. Y'all know what I'm saying? So do the algebra. That's like all the little practice problems we give you. Work them out until they're complete. I know it's not something you probably rather be doing anything else, but it's something that I think you will benefit from. Okay, so now what I need to know is when is this thing 0? When does it equal 0, and when does the bottom equal 0 also? When is it undefined? Okay, so answer me this first. The bottom is x squared plus 3. When does that equal 0?
It is. I don't think it can.
It doesn't. Doesn't ever equal 0, because what does that squared do to any negative I put in there? Makes it positive. And if you think about it, x squared plus 3, if I were to just to graph that little piece, that's a parabola, right? And how is it transformed?
By that cube.
Well, I'm just talking about the x squared plus 3. How's it transformed? Up, right? And then it opens which direction? Okay, so you guys learned that solutions are the same thing as x-intercepts. Does that have any x-intercepts? None. Okay, so nothing. Also, if you tried to solve it, x squared plus 3 equals 0. X squared equals negative 3. The square root of a negative is not real. So those are all those ways. So I don't have to worry about that, which is nice. So it's the top that I got to deal with. So what I'm looking for is 36 ever 0. No, it's never 0, but x squared minus 1 might be. So x squared minus 1 equals 0. That's the difference of two squares, so that's x plus 1. X minus 1 equals 0, so x is equal to plus or minus 1. The other way to solve that is to send that 1 over, take the square root of it, and you get plus or minus 1. Okay? So my intervals are going to be from negative infinity to negative 1, from negative 1 to 1, and from 1 to infinity. Test values. What do you think? Negative 2?
Yes.
What's this one? 0, 2. Sine of the second derivative. Okay, the sign of the first derivative tells us what? First derivative. Good. Increasing or decreasing. Sign of the second derivative, concave up or concave down. So plug in a negative 2. I'm going to plug it in right here. Negative 2 squared is 4. Minus 1 is positive 3. The bottom is always positive, right?
Yep.
So that's what? Plug in a 0. 36 times negative 1 is a negative 36. the bottom's always positive, so this one actually is negative. Plug in a 2, get the same thing as we got when we plugged in negative 2. So this is concave up, concave down, concave up. All right, any questions about that? Okay, points of inflection. So here we go. A point of inflection of the graph is a point where the concavity changes. It's where concavity changes. So if this point is a point of inflection, then f prime of, or f double prime, so the second derivative either equals 0 or it does not exist. That's why we set that whole thing equal to 0 or set it where it's undefined. And that's where we're able to find. So in this case, where are our points of inflection? This goes from concave up to concave down. So what that looks like graphically, concave up goes like this, and then concave down starts to go down. So somewhere in there is a point of inflection. Where is it on this graph or on this problem? Concave up to concave down. Where does it change? At -1. And -1 happened to be where our second derivative was equal to 0. Does that make sense? It's neither there. It's changing. Also right here, the positive one. Okay, any questions? Okay, so let f be a function such that the first derivative of at c is equal to 0 and the second derivative of f exists on an open interval containing c. The second derivative test says if the second derivative is 0 or less than 0, then it's a relative minimum at that point. Okay, so think about that. It says if the first derivative is 0, what does that mean? First derivative is 0. It means it's got a horizontal slope. And what that means is it's either going like this horizontal slope or this horizontal slope right there. So what this says is that if the second derivative is negative, that means it's concave what? Second derivative is negative, concave down. Then this, okay, if the second derivative is negative, it's concave down, then this is a relative max. So change that. Okay. So the first derivative is 0 and the second derivative is negative. It means it's a maximum. Does that make sense? That's concave down. That's a max. Okay, if it's positive, that's what we have here. Second derivative is positive. It's concave up. Then this is a minimum. If the second derivative is equal to 0, then you got to use the first derivative test. It may not be either. Who knows what it is. Second derivative could be 0 for a lot of reasons. A linear function has a second derivative of 0, and it's not concave at all. Okay? Everybody made these changes?
Yep.
Okay. Last example. Here we go. Find the relative extrema. So what does extrema mean? Min or max. There we go. So what's the first step? First derivative. And this is negative 15x to the 4th plus 15x squared. Everybody with me on that? So where does this equal 0? That's the first thing we need to know, right? Where does it equal 0? So I'm going to factor out a negative 15x squared, and I'm left with x squared plus 1. That's actually a minus 1. Why is it minus? Because I took out a negative. All right, so x squared minus 1. So where does this equal 0? When x is 0 and when x is equal to what? Somebody said it. Plus or minus 1. Does everybody see how I get plus or minus 1 from here? Okay. All right. The second derivative test tells me that if the first derivative is 0, which is here, and the second derivative is either positive or negative, I can tell what is a max or a min. Okay, so let's take the second derivative now. And I'm going to go back up here to this. So this is going to be 4 times negative 15 is what? Good. X cubed plus 30x. Factor out a negative 30x, and I get 2x squared minus 1. Okay, so this is my second derivative. Now, the test says, if we go back to that previous page, at this point, and this point, and this point, if my second derivative is positive or negative. So what I want to do now is I want to plug in this point into my second derivative. And when I do, I get 0. Okay, so let's plug in 0 first. Well, let's just do it like this. Yeah, so the point at which we're talking about is going to be negative 1, it's going to be 0, and it's going to be positive 1. Okay, that's what x equals. All right, so we'll plug in a negative 1 first. That makes this out here what?
0.
Positive. And then that's 2 minus 1 is what? 2 minus 1 is positive 1, so positive and positive makes it positive. Plugging in a 0. That's a 0 out here. That's negative 1 in here. What's 0 times a negative?
0.
0 times a negative is 0. So it's neither in that case. And then when I plug in a 1, I get a negative and a positive. What's negative and positive? Negative. Okay. So this is a what? First derivative is 0. Second derivative is positive. It's concave up, and so that makes it a what?
Min.
A min. So the second derivative test tells us a min. So there it is, concave up, and there's our minimum. Slope is 0. This one, the test fails.
Fail.
And then what about this one?
Maximum.
Relative max. Okay. Now the only thing left to do, it says the point. So what is my y value for each of these? Where do I go get my y value for my function? To the original. So f of negative 1 is equal to negative 3 times negative 1 to the 5th plus 5 times negative 1 cubed. So that's still negative 1 times negative 3 is positive 3 minus 5 is equal to negative 2. So I have a minimum at negative 1 comma negative 2. I'll plug in 0. 0 and 0. That leaves 0. And then f of 1 is equal to negative 3 times 1 to the 5th plus 5 times 1 to the 3rd. That's negative 3 plus 5, and that equals 2. So what does that mean? It means I know where my mins and maxes are now. I know if it's concave up or concave down. So
Did it.
we did it.
Lonely seasons. Oh.
Even if it's like a Marvel movie where if you wait till the end and the curtain turns off, you get like an extra little 5-second clip, but instead they're just gonna be hating or you being an idiot.
Oh, okay.
You should make an end credits.
The recording.
Never mind.